So, welcome back. Another session. Hey, in the first session that I did today, I talked about Silverlight 5. In this session, I'm going to shift gears quite a bit because I want to talk about Windows phones. And before I start talking about it, I want to give you a bit of a testimonial because until a few months ago, I was a very loyal iPhone user. I know, big booze. And I'll be honest with you, when I started building code for Windows phones, I knew that ultimately I was going to have to give that iPhone up, and I was going to have to carry a Windows phone because you want to walk the walk as well as talk the talk, right? But I really dreaded that day because I thought, when I give up that iPhone and I start carrying that Windows phone, it's not going to be any fun. But a funny thing happened. While there are a few things that I miss about my iPhone, there are more things that I would miss about my Windows phone if I gave it up. So today, my wife has my iPhone. I don't use it anymore. And I carry this around. It's a Samsung Focus. It's my favorite smartphone, the best one I've ever owned. And of course, it only gets better when the next version of Windows Phone 7, codenamed Mango, comes out. And I'll tell you something else, too. And I'm just giving you a personal opinion here. I started in this industry almost 30 years ago, back when the IBM PC first came out. I was fresh out of college, and it was an exciting world back then because there was this new thing called the personal computer, and we were all excited about it. We knew millionaires were going to be made. We knew companies would be built around it, and indeed they were. But our little industry hasn't been that exciting in many, many years because, to be honest with you, almost every great piece of software that needs to be written has been written, or at least it seems that way sometimes. But I'm having more fun than I've ever had right now because most of the development that I'm doing these days is not for the desktop. It's for mobile devices like this. It's fun because there's still lots and lots of software that needs to be written for this, and that's even more true of the Windows Phone than it is the iPhone because it's newer. And tomorrow, we're going to be writing mobile type applications for other types of devices like slates and pads and things like that. So again, it's just a personal opinion. I could be wrong about this because I've been wrong many, many times before. But folks, I think this is where the action is in the next few years. Does that mean we won't be writing desktop applications anymore? No. We'll still be writing those. We still need to build line of business applications that run behind the firewall and all that. But you know what? This is where the real action is going to be. Folks, this is where the money is going to be made. If you're not already a Windows Phone developer or a mobile developer of some sort, then there is no time like the present to get going with that. So that's why I put this session together, because if you're already a Silverlight developer, you know a lot about Silverlight. Maybe you know everything there is to know about Silverlight. Well, the good news is you can become a mobile developer fairly easily, because Microsoft chose to make Silverlight for Windows Phone the primary programming platform for Windows Phone. But there are some things that you need to know before you start down that journey. Yes, there are differences between Silverlight and Silverlight for Windows Phone. In this next hour and 15 minutes or so, I'm going to go over some of those differences, and my goal is to take you, the Silverlight developer, and to teach you as much as I can in that period of time about what you need to know to build applications for mobile devices like the Windows Phone, and in the future for who knows what types of devices. So, let's start down that road. The very first thing you should know about if you're a Silverlight developer who wants to start building mobile applications is page orientation. Now, obviously, when someone is running your application on one of these phones, there's nothing to prevent them from taking the phone in its upright position and turning it on its side. Now, we don't worry about those kinds of things when we're building desktop applications because how likely is it someone's going to pick up the monitor on their desk and slam it down on one side? Even if they do, they don't expect the software to behave any differently, right? But they will expect this to behave differently. Most applications, not all, but most, when the phone is turned, will rotate. Now, I want to show you how to make it rotate. And the really cool thing is there's next to nothing that you have to do. But the more interesting case occurs when you want control over how that display changes when the phone goes from the landscape orientation to portrait or vice versa. It turns out there's an event that Silverlight for Windows Phone exposes to us that allows us to know when the phone is turned and allows us to update the UI as we see fit rather than as the runtime sees fit. Now, you get a lot for free. When you create a new phone project in Visual Studio, if you look inside mainpage.xaml, up near the top of the page, one of the things you'll find in that XAML is a line that assigns a value to a property of the page named supported orientations. In fact, that line may look like the one you see here on the slide in front of you. When you say supported orientations equals portrait, that means the runtime should consider this phone to always be in portrait mode, regardless of whether it's upright or it's on its side. So in this case, the display will not automatically rotate, as you can see from this example taken in the Windows Phone emulator. But if you change that from portrait to portrait or landscape, you're telling the Silverlight for Windows Phone runtime that you want it to automatically rotate that display 90 degrees. So, without doing anything else, without writing a single line of code, you can get the kind of behavior that you see in these screen captures right here. But again, the more interesting case is when you want to take control over what happens when that phone is rotated. And a classic example of this is the calculator that comes with the Windows Phone. If you've used that calculator, and it's a lot like the iPhone calculator, when the phone is in portrait mode, it's a simple, just arithmetic calculator. But if you turn it over onto its side, more buttons appear, and you have a scientific calculator. You have to write a little bit of code to make that happen, to actually change what's shown on the display. And this is what that code looks like. When your application starts up, or sometime thereafter, you register a handler for the orientation changed event fired by the page. Then, when that event fires, you adjust the display. When it fires, the first thing you'll probably want to know is, okay, what is the phone's current orientation? Is it upright? Is it portrait? Or is it on its side? Is it in landscape mode? So I'm showing you here in this code snippet how to make those checks. And by the way, you can be richer than what I've shown right here. You can find out if the phone is, say, in portrait mode, is it right side up or is it upside down? If it is in landscape mode, is it on its right side or is it on its left side? All of that information is available to you here in this orientation changed handler. Now, I'll show you an example here. In fact, a couple of examples. I'm going to pop up Visual Studio here. And I'm going to first open a little project that you can download and try out for yourself. In fact, let me give you a URL. If you were in my previous session, this is the same URL that I showed there. But if you weren't in that session, then you haven't seen this URL, so let me bring it up. And it is right here. You can go to this URL at your convenience. Let me make this a period rather than a slash. And you can download a zip file containing all of the samples that I'll be showing in this session and the samples that I'll be showing in other sessions here at this event. winterlight.com/downloads/devdays2011.zip. Hope you've had sufficient time to write that down. Let's go back to Visual Studio, and I want to open a project for you. I want to start with something simple. It's called Orientation Demo, and it is designed to demonstrate how you can take charge of what happens when the orientation of the phone changes. So I'm going to fire it up here. We'll start it in the Windows Phone emulator. I'm running it with a hardware assist here, so it'll take a few seconds to boot up, but then we'll be running a copy of Windows Phone 7 here in a VM. Actually booted up even faster than I expected. So here it is running in portrait mode, but I'll click this to kick the phone over to landscape mode, and you can see that the display changed because now I'm showing one penguin rather than two. In fact, one thing I intend to do and simply haven't had time is I'm going to make it so every time the orientation changes, another penguin is added, so you can shake the phone back and forth and you'll create a family of penguins. I just haven't gotten there yet. You can make that change yourself if you want. But let me show you how this thing works. We'll kick it back to portrait mode, where you can see that one of the penguins disappears. And all I'm doing in this example is exactly what I showed you in the slides. When the application starts up, I register a handler for the orientation changed event fired from the page. Then, in that event handler, all I'm doing is toggling the visibility of a user control representing that second penguin. In fact, this is typical when we do take charge of how the display changes, when the orientation of the device changes. We typically just show or hide XAML elements that are already sitting out there in the visual tree. In fact, let me bring up one other project that shows this also in a little bit more realistic way. This is actually an application that I recently published to the Windows Phone Marketplace. It is a reverse Polish notation calculator. Because my background, my formal education in the old days is in engineering, I never really learned to use a normal calculator. I have to have a reverse Polish notation calculator. So this is one of the first apps that I wrote for Windows Phone. And the reason I want to show you this is simply this. Like the calculator that comes with the Windows Phone, in portrait mode, it is a simple arithmetic type calculator. If I want to add 2 and 2 with a reverse Polish notation calculator, I'll click 2, enter 2 plus. But if I kick this thing over onto its side, like the calculator that comes with the phone, it becomes a scientific calculator where I have additional buttons like 1 over x, sine, cosine, tangent, square root, and things like that. All I'm doing to make that happen, folks, is taking that orientation changed event and hiding 2 columns worth of buttons when the phone's in portrait mode, or re-showing them, re-displaying them when the phone is in portrait mode. So, if that matters in an application you build for the phone, if you want the display to automatically rotate, you know how to do that. If you want to actually take control and specify yourself what happens when the phone rotates, that is when its orientation changes, hopefully you now know how to do that. And with that, I'll pop back over to PowerPoint and get on to the next topic. Here's something else that every Silverlight developer needs to know about when they start building phone applications, and that is SIPs, software input panels. Most Windows phones don't have a hardware keyboard. In fact, when I bought my Samsung Focus, I did not want a hardware keyboard because I wanted that phone to be as thin and as light as it possibly could be. Therefore, when I want to enter some text, the operating system pops up a software keyboard, better known as a SIP, or software input panel. Now, it turns out that Windows Phone 7 has more than 60 different SIPs built into it. If the user is typing in a phone number, it might display, for example, the SIP that is designed specifically for phone numbers, the one that looks like a telephone keypad. But if the user is typing in a text message or an email address or something like that, the operating system will probably display a more conventional software keyboard. But here's the key. The operating system has no idea what you're expecting a user to enter into a text input field. You have to tell it that. And you do that by using the input scope property that was added to text input controls in Silverlight for Windows Phone. In other words, anytime you declare a text input control like a text box, you should also ask yourself, what software input panel or software keyboard do I want the user to see when this text box has the input focus? And then use that text box input scope property to tell the operating system which SIP to display. If you're putting a text box in there specifically for the user to enter a phone number, then you might do what I've done here and set input scope to telephone number. Now, I said that there are more than 60 of these software input panels than there are, but to be honest with you, there aren't that many different ones. At least it doesn't feel that way. There are 5 or 6 basic SIPs. The other 55 or so come from small variations in the existing SIPs. For example, if you ask Silverlight for Windows Phone to display a URL SIP or an email address SIP, it basically takes the default SIP and shrinks down the spacebar and adds a .com key to it. But it is true, nonetheless, that there are more than 60 different SIPs, and also true that whenever you declare a text input control in a phone application, you should also attach an input scope property to it. Now, here's a very simple example of that. Let's go back to Visual Studio, and let's open a different project here. This one is called Input Demo. Actually, I want that to go to my controls. Here we are, Input Scope Demo, right here. So what you'll see here when this runs, and I'll run it in the emulator because there's no reason to run it on a real phone, is a simple data entry type application. Maybe it's one page of a larger application. But in it, the user can enter a name, a phone number, and an email address. When any one of these text boxes receives the input focus, a software input panel is displayed. Now, what I've done for this name text box is just ask the operating system to display the default SIP. Therefore, you see that default generic keyboard right there. However, when the user puts the input focus in the phone field, I want the operating system to display a numeric keypad, much like the one that they use to dial a Windows phone. I do that through the input scope also. All I've done is set input scope on that text box to telephone number. Then, when the user enters an email address, you can see that when that text box receives the input focus, I've actually used a different input scope there, which lets the operating system display an email SIP. How does it differ? Well, this is one example. Notice it doesn't look that much different than the default SIP, but the space bar is smaller, and there's a .com key here. In fact, if you hold it down, you'll see other extensions that you can choose rather than .com. So subtle difference, but important when it comes to helping the user enter whatever it is you've asked them to input. Now, the code for this, actually I should say the XAML for this is just as simple as it can be. If you look in mainpage.xaml, you'll see those three text boxes declared, and you'll also see that on each one of them, I've used the input scope property to tell the runtime exactly what type of software keyboard I want displayed. Let's scroll down so that you can actually see that. Here are the text boxes right here, and scrolling out just a bit, you'll see that they all have their input scope set. Here I'm asking for the default SIP, here for the telephone number SIP, here for the email SMTP address SIP. Not a big deal, not a difficult thing to do at all, but something that you should think about, again, anytime you declare a text input control in a phone application. All right. Back to PowerPoint here for just a minute, because I want to talk for just a moment about stock resources. Now, these are documented, but it still seems that a lot of phone developers don't know about them. But in fact, you need to know about them because they enable you to build phone applications that look like other phone applications. They also enable you to build phone applications that adapt to the theme and to the accent color that the user selects through the phone settings. Now, if you don't know what that means, that's okay. I'll show you a demo here in just a moment. So here's the deal, folks. Hardwired into the Windows Phone operating system, technically into the Silverlight for Windows Phone runtime, is a set of stock resources that relate to fonts. There are stock resources for font families, for font sizes, and for font styles. I haven't listed all of them in this slide, but I've listed a lot of them. Now you may wonder, yeah, but why would I ever care about that? Why not, if I want to set the font size to something, why not just set it to 16 or 32? Well, you can always do that in Silverlight for Windows Phone. But you got to remember that one of the things we'd like to do is be consistent with other applications. In fact, this type of UI right here is a fairly common one seen in phone applications where we have a list box control showing a list of items. We might even use a pivot control to allow the user to scroll sideways and see different pages of the app. But what I've done here so that this display in my app looks like similar displays in other apps is I've used default or stock styles for the fonts here, and I've listed those in this slide. I've got text block style equals static resource phone text normal style, for example. The second one, text block style equals static resource phone text title 1 style. Again, we use these to make our applications look like others. If you've never done this in Silverlight, it's done fairly easily. This shows how it's done syntactically. Notice I'm using the static resource markup extension. The syntax is exactly the same as if I'm referring to styles that I've defined myself, perhaps over in app.xaml. The difference is I'm referring to a stock font resource, one that's part of the runtime. When you install the Silverlight for Windows Phone SDK, they actually give you a XAML file with the source code for these resources in case you want to take a look inside to see what makes them work. In addition to giving you stock font resources, the Silverlight for Windows Phone Runtime also gives you some stock brush resources, which you can use not only to make your application look like others or be consistent with them in terms of the colors that it uses, but using these stock brush resources allows your phone application to adapt to changing user preferences. As an example, when a user purchases their Windows Phone and sets it up, or any time thereafter for that matter, they can choose between a light theme and a dark theme, black background, white background. They can also choose an accent color, which among other things determines the color of a lot of the tiles out on the start screen, but also shows up in other places. The magic thing about these stock brush resources is that they change as the system colors change. In fact, I've shown an example here where the phone, let me see if I can read it from here. Yes, notice the third block down, phone background brush. Notice how when the user has a dark theme selected, that brush is very dark. In fact, it is black if I remember correctly. Notice phone foreground brush when the user selected a dark theme is something that's rather light, something that will show up against that dark background. But if they choose the light theme on their phone, look how phone foreground brush and phone background brush change. This is not just a matter of making your applications look like others. It's a matter of adapting to those user preferences. And if you want to leverage those stock brush resources, the syntax for doing it is exactly the same as that for leveraging custom resources that you've defined. Once again, I use the static resource markup extension in XAML, but this time I'm referencing brushes that are built right there into the runtime. Let me show you an example of what I mean here, and of how when you build an application, if you want it to behave well when the user changes color settings, themes, accents, etc., this is what you need to do. So let's go back into Visual Studio and open a different project. This one is called Brush Demo. It is also part of that zip file that I gave you the URL for a few moments ago. And here's what it looks like when it runs. Let's get it up and running in the emulator. And you can see that initially, everything looks sort of dark. I've got some text in this display. I've also got a gradient background. But now we're going to see how it responds if the user changes the phone settings. What if, for example, the user chose the light theme rather than the dark theme? Is my application going to respond to that? We'll find out. So we'll go into Settings, go to Theme, and we'll change select light rather than dark. Now let's go back and restart my application. Brush Demo right here. And you can see that it has adapted. Instead of having a black to blue gradient fill in the background because the user has now chosen the light color theme, I'm now filling that background from white to a lighter shade of blue. One other thing the user might do is change the accent color. Right now, I'm using the default accent color, which is blue. How's my application going to respond if the user chooses a different accent color? Well, let's once more go out to the settings on the phone. And this time, I'll change the accent color to something else like orange. And now let's go start that application again. I guess I could have just pressed the back button a few times, but it doesn't really matter. So now, not only are we honoring the theme that the user has selected, but we're honoring the accent color too. Notice that the color of my title text is changed to the selected accent color. And I've even changed the brush used for my background gradient from blue to orange. Now, what does it take to build an application that adapts to the user's preferences this way? And by the way, this is something you should think about whenever you build an application. Before I go further, let me do this. I want to go back and undo what I've done, or things may look really nuts later on. So one more time, back to Settings. And by the way, while I'm doing the reset, we'll just make sure that our application behaves appropriately. So I'll go back and change, select blue again. There we are. Wrong one. There we are. And if I do back a couple of times, hopefully we'll go right back into the application. Well, wrong one. We'll just start it from scratch again. And you can see that it's gone right back. Folks, all it takes to build an application that adapts its colors this way is to use those stock brush resources. Take a look here in the source code. In here, this is mainpage.xaml. When you scroll through here, here's what you'll find. You'll see me declaring text blocks, for example, for those titles at the top. You see me using a linear gradient brush to fill the background of the grid at the root to create that gradient background that you saw. But instead of hard-coding colors, instead I'm using static resource statements to reference the built-in brush resources. Then there's literally nothing else that I have to do because I'm relying on those stock brush resources and because they change automatically in the runtime as the user changes the theme and the accent color, my UI will adapt as well. Couldn't be a whole lot easier than that. But of course, you have to know that these stock brush resources exist. In my experience, it's something that's missed by a lot of Silverlight developers who are coming over from the desktop. Therefore, I wanted to make you aware of them. What else do we need to know about? Here's one of the biggies. When you're going from the desktop to a phone, you have to think about touch input. Because after all, you don't often see someone with their phone with a mouse attached to it. In fact, have you ever seen that? I don't know if you can even buy a real mouse for a phone. That's because these phones have touch screens. In fact, every Windows phone is required to have a touch screen that supports capacitive touch with at least 4 fingers at the same time. You can build some crazy interfaces with 4 fingers. Now, to be honest with you, you probably never really want to recognize up to 4 fingers on that screen at once. Might be good for a tablet device or for something else, but that's a lot of fingers on a small phone. But the very fact that you can do it means that you should know how. In addition, when it comes to phones, we often want to do a lot more for the user than what we could do for them on the desktop with a mouse. We may want full gesture support so the user can tap something on that screen, or so that they can use 2 fingers and zoom something, or 2 fingers and rotate something. How do you build rich touch interfaces into a phone application? Well, believe it or not, there are 4 ways to go about it. I want to briefly go through those 4 ways here, talk about touch input on a phone, and emphasize the things that you should know if you're a desktop developer who probably has little or no experience building touch interfaces. The first thing that you should know is that one way to build a touch interface into a phone app is to use mouse events. Those very same mouse events that you probably used in Silverlight for the desktop before still fire in Silverlight for Windows Phone, but they now fire in response to touches with a finger or other body part. You can't really tell what part of the body it is. You can't tell whether it's a finger or a toe. But those same mouse events fire. The user puts a finger on the screen, Silverlight fires a mouse left button down event. The user moves the finger, Silverlight for Windows Phone fires a series of mouse move events, and when that finger leaves the screen, Silverlight fires a mouse left button up event. Now, what does this mean? It means that if you're porting an existing application from the desktop to a phone and you have mouse handling logic in it, you'll probably get a whole lot for free just by porting it over and relying on the mouse events that Silverlight for Windows Phone is firing. In fact, if you're just concerned with single touch, you don't want to do anything special like pinch zooms, this may be all that you need. It's also an easy way to get a touch interface up and running without getting involved in learning all the details of low-level touch in Silverlight for Windows Phone. So yes, we can simply use mouse events. And in fact, I've got applications that do that. Let me just pop over into Visual Studio and show you one. In fact, better than that, I'm going to pop over to this Wolf Vision device here, put my phone on there, and we're going to run the application right here. There we go. So the application I'm looking for is one named Silverlight. This is also available for free in the Windows Phone Marketplace. It's a Silverlight for Windows Phone adaptation of the famous game of life where you draw patterns of cells like I'm doing here, and then you use John Conway's genetic algorithms to step to evolve that grid of cells from one generation to the next. If I press this key here, I evolve them one generation. If I press the start button, they'll just go and go and go until they die or they reach a steady state. Now, wow, that's kind of cool. It's going. It's actually hard to get one that goes on for a while. By the way, a little piece of trivia for you. When you get a repeating pattern like this in life, you know what that's called? Does anyone know what that's called? It's called a pulsar. When you think about it, it looks sort of like a pulsar, doesn't it? I'll stop it. But again, the main reason I'm showing you this is that this application does have a simple touch interface. Right here, as I drag that finger around the screen, you see the cells underneath the finger toggle on and off. If you look at the source code for that application, there's nothing there that is touch specific. All I'm doing, essentially, is processing mouse enter events, which have been around in Silverlight for the desktop for ages. I'm just processing mouse enter events here. And as the finger moves around the screen, Silverlight for Windows Phone treats it as a mouse cursor, and all I'm doing is toggling cells on and off by changing their visibility to make them bright or to make them dim. So in that case there, I elected not to do anything more sophisticated than process mouse events because there was no real need for multi-touch in this app. Now here's one thing about this application. If you download it, put it on your phone and try it, you'll find that you too can drag a single finger around the screen and you can toggle cells on and off. But if you take two fingers, put them on the screen or at the same time, or put one down then the other and move them, you'll find that only the first finger that touched the screen actually toggles these cells on and off. The second finger is ignored. Here's why. To make these mouse events work, Silverlight for Windows Phone uses something called mouse event promotion. What's really happening way down deep under the hood as that finger moves around the screen is that a series of touch events are firing. But those touch events bubble up in effect and by default are promoted to mouse events. Now you can prevent that from happening, prevent that promotion from happening, although you typically don't care whether it does or not. But the key is only primary touch points are promoted to mouse events. The primary touch point is the first one, is the point where the first finger makes contact with the screen. If I have one finger on the screen, then I put a second one down. Yes, under the hood, events are firing as both of those fingers move around. But only the events, the touch events emanating from the first finger that touched the screen are promoted to mouse events. So using mouse events for touch input lets you use a paradigm you're already familiar with. It typically makes it pretty easy, at least in the initial steps, to port an existing desktop application over to the phone. But if what you really want is a multi-touch interface, you cannot get that with mouse events. So, obviously, mouse events are not the end of the story. Well, I told you that there are 4 different ways. Make sure I press the right button here. There are 4 different ways to build touch interfaces for phones. The second is this, frame.touch reported events. Now, some of you may have used these events in Silverlight for the desktop. They actually do exist there. And if you're one of the lucky individuals who is running Silverlight applications on a desktop monitor with a touchscreen, you can use these events in a desktop application to build very rich touch interfaces. My experience, however, is that most Silverlight for desktop developers don't develop for touchscreens. So even though these have been in the runtime since Silverlight 3, most developers have never been exposed to them. Therefore, we're going to talk about them here. So, this is the lowest level at which you can process touch input on a Windows phone. There's a lot you can do, but as you're going to see, because it is so low level, it doesn't give you built-in support for gestures. Yes, I could build a pinch, zoom, or unzoom interface using these events, but I don't do it that way because there are easier and better ways to do it. What these do, however, is report to you everything that happens on that phone's screen involving touch, with as many fingers as the user cares to put down. Remember, Windows Phone is required to support up to 4-finger multi-touch. It has the option of supporting more. To my knowledge, all the manufacturers today support just 4 at a time. But yes, I could script out very complex gestures here by using these events. So here's what happens. Anytime any finger touches the screen, moves around the screen, or lifts off the screen, the runtime fires a touch.frame reported event. If all I care about is single touch, I don't care how many fingers are on the screen, I want to ignore any but the first one to make contact, then I can process these low-level touch.frame reported events this way. Notice that when my application starts up, I register a handler for that touch.frame reported event. By the way, these events have global scope, not per object scope. In XAML, individual objects fire mouse events. So I can put a XAML rectangle on a screen, I can register a mouse left button down handler for it, and then I don't have to do any hit testing because that event only fires from that rectangle when that rectangle is touched. In the event handler, I inherently know where the event came from. Frame.touch reported events are very different. They're not affiliated with any object in the XAML DOM. Instead, they're fired globally, if you will, from the runtime. So there often is some work to do to hit test your scene and find out exactly what it was that the user touched. But this example right here shows about the least amount of code you can get away with to use these events. Each time one fires, I'm first calling touch frame event args get primary touch point. I'm saying here, I don't care how many fingers are on the screen, I want information regarding the first one that touched the screen. Then I want to know, so what did this finger just do? Did it just now touch down on the screen? Did it move or did it lift up? So I'm checking the action property of the touch point object that comes back from get primary touch point, and if it is equal to touch.down, that tells me that that primary finger or primary touch point just went down. Now, I want to do a little bit of hit testing. In this example, my goal is to put a rectangle up on the page, and when the rectangle is touched, have it change colors from red to blue. To help me do that hit testing, through the touch point object returned by get primary touch points, I can call directly over and I can pass in a reference to a XAML element. And that will return true if, indeed, the object whose reference is in directly over is the object whose reference that I compared it to. Now, if you want to do more complex hit testing, if there are many objects on your scene that you want to do something to in response to touch, you'll have to build the logic to do that. Remember, touch.frame reported events are designed to serve as low-level touch events. If you want something more than that, you have to build the logic yourself. But here's something kind of interesting, folks. When I do what I'm doing in this slide right here, I'm only responding to a single finger because of the fact that I'm calling get primary touch point. Remember, that by definition means the very first finger to touch the screen. What if I wanted true multi-touch support? What if I wanted, for example, to modify that Silverlight application so you could put 2 fingers on the screen and drag them around to toggle cells on and off, or maybe even 3 fingers or 4 fingers? How would I do that in a phone application? You do it with touch.frame reported. In fact, touch.frame reported events are the only way to build general purpose multi-touch interfaces in Silverlight for Windows Phone. Take a look at this code here. It's very similar to the code you saw on the previous slide, but there's one very important difference. Instead of calling get primary touch point, I'm calling get touch points. That returns to me an array of touch point objects. There will be one element in that array for each finger that is in contact with the screen. So let's say now that we want the user, again, to be able to draw cells into Silverlight with 2 fingers at the same time. This code allows me to do that. I ask for an array of touch points. Again, if there are 2 fingers in contact with the screen right now, that will return an array of 2 touch point objects. Then, for each of those touch point objects, I can do hit testing to figure out where that touch point currently is, what cell or rectangle it's over. Then I can toggle that rectangle on or off or do whatever I want. Again, this is the only way to build general purpose, generic, multi-touch handlers in Silverlight for Windows Phone by processing frame.touch reported events. Now, to demonstrate this, let me show you something over here. Go back to my phone for a moment and unlock it. And I'm going to run a different application here called Frame Reported Demo, Frame Reported Touch Demo. So here's what it looks like. It's a simple application that shows two rectangles, one red and one blue. And when I touch either one of those rectangles, it highlights the rectangle by turning it to yellow. And I can take the rectangle and I can drag it around like that. I can do the same thing with the blue rectangle like this. Now, what I've done so far, I don't really have to have frame.touch reported events for. I could do that with mouse events because I'm only using single touch. But here's something that you cannot possibly do with mouse events or any other way in Silverlight for Windows Phone. I'm going to touch first one of those rectangles, then the other, and I'm going to move them both at the same time. The only way to build that kind of interface, again, is to process frame.touch reported events. Now, how does it work? Let me give you a peek behind the scenes at the source code. And this, too, by the way, is in that zip file that you can download to go with this session. Let's go back over into Visual Studio and open this thing up. And that's going to be under Touch Demos, specifically Frame Reported Touch Demo. So, when you look at mainpage.xaml, it's pretty simple. I have little more declared there than a couple of rectangles, the red one and the blue one. And I have a translate transform attached to each of them. That's because in order to make those rectangles follow the finger, as I get frame.touch reported events telling me that fingers are moving, I'm going to use the translate transform attached to each of those rectangles to actually move the rectangle around inside this scene. So not a lot there in mainpage.xaml. Most of the work is in mainpage.xaml.cs. When this application starts up, one of the very first things I do is register a handler for frame reported events, as you can see right here. Now again, anytime a finger touches the screen, moves on the screen, or lifts from the screen, this event handler will be fired. Notice here, because I am specifically interested in multi-touch, I'm not calling get primary touch point. To do so would be to ignore any finger but the first. Instead, I'm calling get touch points. In that example that I just ran, I had two fingers at a time in contact with the screen. While that was happening, while those fingers were moving, the events were firing, and every time I called get touch points, I was getting an array of two touch point objects. Now, I had to do a little bit of work here to figure out exactly what is underneath that finger. What if the finger goes down outside one of those rectangles? Well, clearly then I don't want to change one of those rectangles to yellow and have it start following the finger, so I have to do some hit testing. How do I do that? I first find out, did the finger just go down? And notice, by the way, I'm doing this in a for each loop, so I'm basically doing this processing for each touch point object in this collection. That means for each finger that's currently in contact with the screen. If the finger just went down, I want to know, was there a rectangle underneath it? So I do some comparisons to find out if either the red or the blue rectangle was underneath. If the answer is no, then I don't do anything else. But if the answer is yes, then I change that rectangle's fill color to yellow so that it becomes highlighted. And then I do this. And this is one of those little subtleties that you may not appreciate until you run into it the first time, but it's something that you will run into if you're building multi-touch interfaces for the phone. Once that finger touches that rectangle, once the finger begins moving, I'll want to move that rectangle. I'll want it to follow the finger. But how do I associate that finger with the rectangle that I want to move? After all, there may be two fingers in contact with the screen at any one time, each in contact with the rectangle. Both fingers may be moving. I'll want to move both rectangles. Well, it turns out that inside the touch point objects that are returned to you by the call to get touch points, you have a property called touchDevice.id that uniquely identifies the finger that corresponds to this touch point. What I do here is build a little in-memory dictionary to associate the ID of a touch device, that is a finger, with the rectangle that finger is touching. Then, later on in my touch.frameReported event handler, if instead of determining that the finger just went down, if the finger is moving, then I make a quick trip into that dictionary to find out if that finger is currently associated with the rectangle. If the answer is yes, I move the rectangle with the finger by manipulating the translate transform attached to it. If the answer is no, in other words, if that finger is just down outside one of those rectangles and moving around the screen, I know that there's no association because try get value will return nothing. And then I have the logic that I need. I also have a little bit of logic in here to handle what happens when one of the phones lifts from the screen. If indeed that finger was in contact with the rectangle, I'll want to change the rectangle's color back to its original value. That's exactly what I'm doing right here. Now, you may look at that and think, gee, that's a lot of work just to move a couple of rectangles around. And the answer is, yeah, it is quite a bit of work, but that's how we do it. It's not easy to build true multi-touch interfaces. You can build great single-touch interfaces easily with mouse events. If you want true multi-touch interfaces, then this is the only way to do it. Frame.touch reported events. And you will almost inevitably end up writing a bit of logic for hit testing and to associate fingers with objects in the scene, as I've done right here. But that doesn't mean that you'll always be using frame.touch reported to build multi-touch interfaces. If what you want is to be able to support something like a pinch zoom, well, that involves multi-touch. That's two fingers on the screen at the same time, moving apart or moving together. But there are other ways to build that kind of interface in Silverlight for Windows Phone without having to deal with low-level frame.touch reported events. Let me show you what I mean. I told you that there are 4 ways to build touch interfaces. We've covered 2 of them, mouse events and frame.touch reported events. Mouse events give you single touch only. Frame.touch reported events give you support for multi-touch, but they do not give you built-in gesture support. What if you want to support pinch zooms? What if you want to support taps or double taps or taps and holds, which are another very common type of gesture used in slates, pads, phones, and other devices? Well, the third way you can process touch input is to use something called manipulation events. Now, these aren't the be-all, end-all. They don't give you a lot of gesture support, but they give you some gesture support. If all you want to do is make something follow the finger around the screen as the finger moves, or if maybe you're showing a landscape photo. It's too wide to fit on the screen, and you want the user to be able to use flicks with their finger to scroll back and forth. You can do that with manipulation events. You can also support 2-finger pinch motions using manipulation events. As you'll see, manipulation events takes the actions of those 2 fingers and consolidates them into one event. So with just a little bit of work, you can respond to an event that says, hey, there are 2 fingers on the screen. They're moving relative to each other. I'm going to manipulate a scale transform to zoom in or out in response. So, here's an example of how you use manipulation events to move a UI element, to make it follow a finger, for example, as I did in that last demo. Manipulation events, like mouse events, are fired by individual XAML objects in your scene. Therefore, there's usually no hit testing to do. It's not like frame.touch reported events, which fire from the runtime and aren't inherently associated with any object. Here I've got a rectangle that I want the user to be able to move and drag around that screen, so I wire up a handler for the manipulation delta events that the rectangle fires as it's moved. By the way, there are 3 manipulation events. There is manipulation started, manipulation delta, and manipulation ended. As you might suspect, the manipulation started event fires when the finger first contacts that object. Manipulation delta events fire as the finger moves around it, and manipulation ended events fire when the finger breaks contact with the screen. There's one downside to using manipulation events. Although this is not documented, unless they've documented since I looked at it, this only works with one finger at a time, with the exception of when you have two fingers on the screen and are using the relative motion between them to mean that you want the scene to zoom in or out. In other words, that last demo I showed you on the phone, the one where I have two fingers on the screen, and I'm not using relative motion to zoom. Instead, I'm moving two rectangles around independently. That cannot be done with manipulation events. Here's one other example, manipulation events. If you want to support pinch zooms in and out, again, you just register a handler for manipulation delta events. Now, here's what happens. When you're processing manipulation events and the second finger makes contact with the screen, a new manipulation delta event fires. And all of a sudden, the scale properties, or the scale property that's accessible to you through the manipulation delta event args, goes from 0 to non-zero. In fact, there's no direct way in a manipulation event to say, is there one finger in contact with the screen or are there two? But by doing the comparison that I'm doing right here in the middle of the slide, by checking scale.x and scale.y for 0, that is a way to infer how many fingers are in contact with the screen. If I see both of those values non-zero, that tells me that in this manipulation event there are indeed two fingers in contact with the screen, and I can use the delta manipulation property to find out by how much I should scale this object in the x and y directions in order to zoom in or out as the user moves fingers closer together or further apart. One mistake developers make sometimes when they first start dealing with these manipulation events is they will write code exactly like you see here, but they'll fail to do that if e.delta manipulation.scale.x and y equals 0 test. And you know what happens when they test their code? When the first finger goes down on the screen, everything that is subject to zooming just disappears. Because when that first finger makes contact with the screen, scale.x and scale.y are 0. If you apply those to a scale transform, boom, the user can't see something that has 0 width and 0 height. So you always want to do this little check right here to make sure that before you scale something, there are indeed two fingers in contact with the screen. But let's talk about the fourth way to build rich touch interfaces for phones. By relying on something that isn't part of the core Silverlight for Windows Phone runtime, but may be someday. It actually relies on something called a gesture listener over in the Silverlight for Windows Phone toolkit. If you want to build real gesture support into your app and you don't want to write all the logic to do it, Gesture Listener is going to be your best friend. In fact, virtually every phone application out there today that supports rich touch input uses Gesture Listener. Now, before I show you how it works, I want to skip ahead. I want to show you the demo to give you an idea of what the Gesture Listener class is all about. So once more, I'll unlock my phone so we can run this demo. And I'm going to run yet another project that's also part of the samples that go with this session. This one is called Toolkit Gesture Demo. Let me find it here and start it up and put it down here so that you can see it as well. So there's our friend Doobie the Penguin again, same penguin that you saw earlier in the orientation demo. But this Doobie the Penguin supports very rich gesture input. For example, I can take one finger and I can move Doobie around. I can take two fingers and I can zoom in and out. But get this, I'm going to do a tap and hold gesture. So I put my finger on the screen and I leave it there. And after about a second, Doobie becomes highlighted in red. In my application, that's my way of telling the user two finger motions, two fingers moving relative to each other, will now be interpreted as a command to rotate Doobie rather than to scale him. So now when I put two fingers down here, this can be hard. I'm going to have to kind of walk around this device. You can see that he rotates around. Now, what if I want to zoom him again? Well, I need to get him out of this rotation mode. So I'm going to do a simple tap, a tap gesture to undo that rotation mode. Now, if I do this, he unzooms. And now, since Doobie's kind of sideways, maybe I want to reset it, I'm going to use, now get this is going to be hard. In fact, you should not try this at home. But I'm going to attempt to execute a double tap with this finger right here. So we'll do the double tap, and everything just reset back to its default state. So there in one application, we see several common gestures. We see drag gestures for moving an object around in the scene. We see pinch gestures for zooming and unzooming. We see pinch gestures also used to rotate an object when it's in rotation mode. We saw tap gestures used to get out of rotation mode. We saw tap and hold gestures used to get into rotation mode. And then we saw a double tap gesture used to reset everything back to the defaults. Now think about this. Could you build that kind of interface using mouse events? No, because some of those gestures did require two fingers. Could you build that kind of interface using frame.touch reported events? Absolutely you could, but you would write a ton of code to do it. To recognize a tap versus a tap and hold, for example, when you see the touch.frame reported event fire indicating that a finger is in contact with the screen, you're going to have to set a timer so that when you get an event telling you that the finger has left the screen or it has begun to move, so you can tell how much of a delay there was between the time contact was made and contact was broken or movement began. So yes, you could build all of that, but you would write a lot of code to do it. I'm going to show you what it takes to build that kind of code using the gesture listener class and the toolkit, and it's so easy. In fact, I'm almost embarrassed how little code it took me to build that demo that you saw right there. But it would have been a lot of code if I hadn't cheated and used the toolkit. So there are 6 basic gestures that are understood by the Silverlight for Windows Phone Toolkit's gesture listener class. The first one is the tap. And it just occurred to me that it would be good if you could see what I'm seeing. You see, that's what happens when you do those complicated gestures like a double tap. It's not just your finger that's involved, it affects you up here. I forgot to switch back. Again, don't try it at home. Triple tap, people have been known to die from doing triple taps, so be very careful with those. So, as I was saying, gesture listener supports 6 different gestures, one of which is the tap. Now, what is a tap really? It occurs when a finger makes contact with the screen and then breaks contact within a short period of time, usually about a quarter of a second, so that we don't have to deal with that, so that our application will work like all others that support taps, and so that we don't have to fool with timers and things. Gesture listener fires a tap event, which we can register a handler for as I'm doing right here. This is a per object event, like mouse events and manipulation events. Couldn't be simpler. If you want to know when something was tapped, attach a gesture listener to it, register a handler for tap events firing from the gesture listener, and then, lo and behold, the event will fire when the tap occurs. What about double taps? Well, again, you don't have to fool with any timers or anything like that. You simply register a handler for the gesture listener for the double tap event fired by gesture listener and attach that gesture listener to a XAML object in your scene. Now in the blue box here, I'm actually showing the sequence of events that fires when a double tap occurs. And if you think back to double-click messages in Windows from years and years ago, you may remember that click messages always preceded double-click messages. Same way with double taps. In order for a double tap to occur, there first has to be a single tap, right? And at that time, the gesture listener has no idea whether that finger, once removed from the screen, is going to touch again. So we see both a tap and a double tap event fire. Obviously, you probably wouldn't want to attach meaning to both tap and double tap events on the same object. But you saw me execute a tap and hold. To get that penguin into rotation mode, I pressed a finger down on him, and I left my finger there until he turned red. Here's how I did that. Very simple. I just registered a handler for the hold event fired by gesture listener, and then executed a little bit of code to highlight the penguin by making him turn red. I also set an internal flag so that now 2 finger gestures would be interpreted as commands to rotate rather than to zoom or unzoom. As far as dragging elements around the screen, gesture listener helps you do that as well. In fact, it makes it very, very easy. Because when you saw me touch the penguin with the finger and start dragging him around, all I was doing was responding to drag delta events fired by a gesture listener attached to that penguin. I'm showing an example of how to do that here. Notice that each time a drag delta event fires, it gives me a pair of properties named horizontal change and vertical change. I can simply apply those to the x and y values of a translate transform, and whatever I'm moving around that screen will simply move with my finger with no additional logic required. Now, there is one thing you should know about. There is one thing the gesture listener won't do for you. In fact, let me go back to my phone for just a moment. Actually, no, I'm not going to take the time to do that since we have less than 15 minutes left. But I want you to imagine this. You've probably seen phone applications before that respond to flicks. Maybe it's, well, here's a good example. If you have a Windows phone and you go into the photo store where all your photos are shown, there are probably too many photos there to fit in one screen. So you can use your finger and you can scroll up and down. You're actually scrolling inside a list box when you do that. You may have noticed, though, that if the finger is still moving when it leaves the screen, the scrolling doesn't stop. Instead, it continues, but the scrolling motion decelerates to give that gesture, that motion, a more realistic feel. If you want to include inertia support, if you're building a scrolling interface and you want the scrolling to continue after the finger leaves the screen, if the finger was still moving when it leaves the screen, here's how you do that with Gesture Listener. You register a handler for flick events. And take a look in the blue box. Let's say that I do put a finger on something and I flick it like that, or I flick it like that. You'll first see a series of drag delta events fire. Those fire while the finger is still in contact with the screen. But here's the magical thing that happens. If, when the finger breaks contact with the screen, it's still moving, Gesture Listener will then fire a flick event, and it will give you information, give you data that you can use to simulate inertia. Now, it will not magically create animations for you to continue that motion. That's up to you. But it does give you the information, like how fast the finger was moving in pixels per second at the moment it broke the contact with the screen. Perhaps more significantly, if the finger was not moving when it broke contact with the screen, Gesture Listener doesn't fire a flick event. So if you want to support gestures with inertia, all you have to do is process that flick event, take the inertia data provided to you in the event args, and apply that to an animation. I've got examples of that I can show time permitting. Also, if you wanted to do pinch zooms using Gesture Listener, well, guess what? There is a pinch delta event that fires each time two fingers in contact with the screen move farther apart or closer together. Doing pinch zooms in that application I just showed you was really no more difficult than doing what I'm showing you right here. And as far as supporting rotations, even though I haven't shown it here, notice that when a pinch delta event is fired, you're provided with a reference to a pinch gesture event args. Here I'm using the scale X and scale Y properties of that event args. Actually, no, I'm using the distance ratio property of that event args to scale something up or down. There's also a property in that event args named total angle delta. If you want to interpret those two finger gestures as a command to rotate rather than to scale, then you ignore the distance ratio property and use the total angle delta property. If you take time to examine the source code for the demo I showed you a few moments ago, you'll see that's exactly what I'm doing when I'm in rotation mode. That is when the penguin is highlighted in red and I see two fingers moving relative to one another on the screen. Now, I've already done this demo, and to make sure that we get through everything, I'm not going to bring up the source code for it right now, but you can pull up that source code, you can see for yourself. What I really want you to take away from what we've discussed in the last 20 or 25 minutes is this. Number one, there are 4 ways to build touch interfaces for Windows phones. Number two, when it comes to building rich gesture-based interfaces, the Silverlight for Windows Phone Toolkit's Gesture Listener class is your best friend. You can do without it if you want. You can build your own low-level touch interfaces through Frame.Touch Reported, but it's a lot easier with Gesture Listener. Here's something else. Gesture Listener actually relies on the touch panel class in the XNA framework, which is implemented in part, at least, in native code. You can try to build your own gesture-based interface on top of touch.frame reported events. Depending on what you're doing and how you're doing it, you may find that performance is not adequate because you're having to interpret those gestures in managed code. So, Gesture Listener, your best friend when it comes to building rich touch interfaces. Here's something else you should know about. If you're moving from Silverlight for the desktop to Silverlight for Windows Phone, it is tombstoning. Now, I'll bet almost everyone in this room has heard of it. If you haven't, you should. Because even though it is simple conceptually, it will be the biggest pain in the rear that you will ever run into in Silverlight for Windows Phone. Now, it changes somewhat in the next release, in the one codenamed Mango. Let me tell you briefly what tombstoning is, show you an example, and then talk about some of the complications that you might run into in real-world projects. Windows Phone 7 is a true multitasking, multi-threaded operating system. However, when you write applications using Silverlight for Windows Phone, only one of those applications is allowed to run at a time. In today's Windows Phone 7, to write applications that run in the background, that is, while other applications are in the foreground, you have to have access to a special toolkit which allows you to write native code, which allows you to access features of the operating system that aren't normally accessible. Microsoft pretty much only makes that toolkit available to OEMs like Samsung and AT&T. So for all intents and purposes, even though this is a multitasking operating system, you today do not have the freedom to write an application that runs in a background. Does that mean, Jeff, that when my application is switched out in favor of another app, is my application really killed off? Is that what you're telling me? The answer is yes. Today, and there's some exceptions to this, but not many. Today, when your phone isn't in the foreground, when your application isn't in the foreground, it is dead. It has been terminated. That process no longer exists on the phone. Now, there are reasons that the Silverlight for Windows Phone team and the WP7 team made these choices. Originally, they were thinking, you know what? Multitasking is not a great thing in some ways because these phones have limited resources available, limited memory, limited CPU time. All it's going to take is a couple of really bad developers writing bad background applications to kill this whole platform. So they said, you know what? We're only going to allow one to run at a time. Now, they have since relented because users like to be able to run applications in the background. In a few months, in Mango, even you and I are going to be able to build background applications. But for today, when our application isn't running, it is dead. It's terminated. The process is gone. Now, what does that mean? Well, it means that if we don't take steps to account for that, a user's probably not going to like our application very much. Let's say the user's running our app. Maybe they've just spent 30 minutes doing some complicated data entry into it. They get a phone call. They answer the phone call. They go back to our application, and all that user input is gone. Are they going to like that application? No. But guess what? When our application is switched away from, if we don't take steps to preserve the data, it will be gone when the user comes back to it. And that's where tombstoning comes in. Tombstoning is the process of hydrating and then hydrating that application so that the data, the state, doesn't go away just because it was interrupted by another application or something like that. In the future, tombstoning isn't going to be as big a deal because applications are going to be tombstoned less often. But guess what, folks? Even in Mango, applications will be tombstoned. They won't be tombstoned as often as they are now. But just as you have to take tombstoning into account when you write a phone app today, you must take it into account when you write applications for Mango tomorrow because there will be times when tombstoning occurs even in Mango. By the way, if you haven't seen any of the cool demos Microsoft has shown, one of the features of Mango, the next version of Windows 7, is called something called fast app switching. You'll be able to easily switch back and forth between applications without killing them off. But let me show you really quickly what tombstoning is all about. In fact, what I'm going to do is go into Visual Studio. I want to show you something because I can make it more meaningful here than I can by showing you a bunch of slides. I'm going to reopen one of the projects that we looked at a few minutes ago. Not that one, but this one, Input Scope Demo. I showed you this one to demonstrate how you use the input scope property to tell the operating system what software input panel, what virtual keyboard to display when a text box has the input focus. Let's run that thing again. Now let's type something in here. So I'll type my name, for example, and we'll type my phone number. We'll say it's 1234567. Now, let's say that the user decides, oh, you know what, I meant to set an alarm so I could give my son a wake-up call. So I'm going to pop back over here, and I'm going to go run some other application on the phone, but as soon as I'm done, I'm going to hit the back button, which goes right back into that application and should present me with the same data that was there before. But because I haven't built any tombstoning logic into this app, all the user input is gone. This is wrong, 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 wrong. We cannot publish to the marketplace an application that behaves this poorly. When the user backs up to your app, the same state they left it in is supposed to be there now, but the operating system will not do that for you. You have to build in tombstoning support. Here's how you do that. Let me open up another version of this that does have tombstoning support built in. And when I run this one, you're going to see that it looks exactly the same on the outside. But because it does have tombstoning support, when the application is tombstone, that is when it's switched away from and the operating system kills the process, the input is not lost. Let's get this input back in here again. I just clicked the start button. Technically, that process was just ended. It's no longer running on the phone. But when I back up to it, because I preserved the state, when it's reactivated, it is untombstoned, and I'm restoring that state there. Now, it didn't take a lot of logic to make this work. In fact, let me show you what it did take. This is the good news, that oftentimes you don't have to do a whole lot of work. So here's what I did. I overrode two very special methods from my base class phone application page. These methods are called onNavigatedFrom and onNavigatedTo. Microsoft's guidance is that to do tombstoning, these are the two methods you should override and do it in. 99% of the time that works. There are some special cases in which you have to actually take other events and other methods, but most of the time this works. But then that begs the question, where do I store the state? There are three possible places you can tombstone state so that it can be restored when the application is reactivated, that is, relaunched. You can store it in isolated storage, which works the same way in Silverlight for the Windows Phone as it does in Silverlight for the desktop, except that it's persisted in memory rather than on your hard disk. Or you can store it in application state or in page state, both of which are unique to Silverlight for Windows Phone. These are just in-memory repositories that allow you to store any arbitrary data you want just before an app is tombstoned so that you can read the data back after it's untombstoned. What I'm doing here is, because this virtual method is guaranteed to be called just before the app is tombstoned, I'm taking the content of those three text boxes and writing them into application state. Then, when the application is reactivated, meaning this method will be called, I'm reaching back into application state and pulling those values back out. I should go a little bit further. I should check to make sure the values are actually there. That is what tombstoning is all about, preserving state so that the operating system can terminate your application, but create the illusion for the user that it was not terminated when they go back to the application, typically by pressing the back key. Now, I don't have time to go into the deeper subtleties, but I will tell you this. In that zip file that you can download for this session, there's a really cool phone application, which I haven't published to the phone marketplace yet, but will be doing soon. It's called Photo Extra Demo. It's a red eye removal kit for photos that are sitting on your Windows Phone. You touch the red eyes, they disappear. You zoom around, you pan, you use all the gesture stuff. It's really cool. If you look at its tombstoning code, you'll see that it is orders of magnitude more complex than what I've done right here because there's a lot of stuff to save. One of the issues I ran into, On page state and application state, there is a limit of about 1.5 megabytes worth of data that you can write to them. But because this is an image handling application, I need to persist an entire bitmap, which can be quite large if that application is tombstoned. So what I had to do was, instead of using application state or page state, I had to write it to isolated storage, where there is technically no limit on the volume of data writing in. But because your application is only given 10 seconds to do its tombstoning or untombstoning, it's very easy when you're writing to isolated storage, because it is slower than in-memory page state and application state, to exceed that 10 seconds. So I had to take care to make sure that that code would execute. I got it down to a second or so for a large bitmap, but it actually took me some effort to get it to that point. Last thing I want to mention here, folks, and we are officially out of time, so I'll keep this to 1 minute. And I just threw this in here because it makes for a really great demo. One of the things you should be aware of, if you weren't already, is that there is a geolocation API built into Silverlight for Windows Phone. It's a very easy to use API, and I included a demo right here that you can play with and dissect if you want. I'll briefly run this for you and then let you go. Let's see, let's bring the application up here. It is called the Location Map Demo, and I'm combining the geolocation API, or the location service, with Bing Maps, so that this application, it looks like I've lost my network connection. Let me see real quickly if I can get that back. Go to Settings. Is my network connection still there? It says connect. There we are. Now it says connected. Let's go try that again, and hopefully it'll be able to tell me approximately where I'm at. So here we go. Using the location service. Nope. The location, I just lost my network connection again. Evidently the wireless I'm connected to is kind of up and down right now. But let me tell you this. This location API is very easy. You can learn everything you need to know about it in 10 or 15 minutes, or perhaps less. It tells you where you are, latitude, longitude, sometimes even altitude, the direction you're moving, the speed with which you're moving, etc. It gets its data from 3 sources: GPS if available, Wi-Fi positioning, when the only location data available comes from the Wi-Fi network that you're connected to. It can also triangulate from cell towers in the absence of GPS data if you have a cellular connection. It's quite amazing. And it allows you to build location-aware applications. Now, Apple and Google are in a little bit of trouble for location-aware applications right now, right? If you've been following the news back home, back in the US, you know that Apple has been caching your location data. Remember that iPhone I gave my wife? When I get home, I'm going to find out everywhere she's been in the last year or so. So if she's got any secrets, she's not going to have any secrets anymore. Windows Phone doesn't cache your location data, or at least if it does, Microsoft isn't telling us, so we can pretend it's not. But I've got a good example in here of that location API. We're out of time. I hope you learned a little something. I hope you all go out and build some great mobile applications. Thank you very much.